Good morning, I'm John Manera. Last year I purchased this Precision Mathews PM30MV mill, and I did a video series on converting this to CNC operation. This video will be a follow-up to that video series, in which I'll be machining these small miter bar cam locks for my Accu-Slice system. This is the most challenging machining operation I completed to date because it requires two separate setups, one to machine the top and one to machine the bottom. I needed to machine 150 of these, so I'm using two vices on the mill, one to machine the top and a second to machine the bottom. I also designed a special jig to hold the systems for the second vise so I can machine 5 of these at one time. The miter bar cam lock was designed using the Fusion 360 software, but I did the actual programming for the G-code using the conversational programming as part of the Centroid Acorn CNC software. The miter bar cam lock is used on the Accu-Slice miter bar rail to clamp the rail into the miter bar slot on the bandsaw. The cam lock is inserted into a slot in the miter bar, and then a brass offset cam is inserted into the center hole and used to move the cam lock forward. Rotating the brass cam 1/4 turn will clamp the miter bar rail into the miter bar slot on the bandsaw table. 3 of these cam locks and brass offset cams are used to clamp the miter bar on the Accu-Slice system securely into the miter bar slot on the bandsaw. This is designed for the miter bar cam lock that was designed using the Fusion 360 software. This part will be machined using 70-75 aluminum. Most of the dimensions have fairly tight tolerances. I could have generated the G-code in the Fusion 360 software. However, I generated the G-code using the conversational programming in the Centroid Acorn software, which is used to control and operate the CNC mill. The actual machining of the miter bar cam lock on a mill is being shown at 5 times the actual speed for viewing purposes. The first step is using a center drill to locate the 5 holes in the aluminum block. Next, a 5/8 inch drill is used to drill the 5 center holes for the cam locks. These holes are drilled completely through the 3/8 inch thick aluminum block. I'm starting out with a 70-75 aluminum block, 4.5 inches long by 1 inch wide by 3/8 inch thick. This size aluminum block enables me to mill 5 of the miter bar cam locks at one time. If I had needed several hundred of these pieces made, I could have designed the system to machine a larger quantity at one time. For viewing purposes, I skipped the tool changes in this video, since the tool changes are manual changes on this mill. This next tool is a 1/4 inch diameter square end mill. I first mill out the oblong center slot, which will later encompass the brass offset cam. This slot is machined 0.18 inches deep, but it is not milled completely through the block. There will later be a 20,000 inch thick rim at the bottom of the slot to hold the brass cam in place. I then use the same 1/4 inch diameter mill to machine the outside parameter of the cam lock. I'm machining in several index steps so as not to overload the 1/4 inch diameter end mill. I then machine the remaining 4 cam locks on the aluminum block. For this project, I did spend a full day setting up and programming the mill and designing the fixture holder for the second vise. When I started the machining process, it took me 48 minutes to machine 5 complete cam locks. I then modified the software to speed up this process. When finished programming, I reduced my machining time down to 25 minutes to machine 5 pieces. In other words, 5 minutes per cam lock. I could have sped this up even faster, but I did not want to sacrifice surface finishes, and the maximum speed of my lathe is only 5,000 RPM. And here's the machining of the 5th and final cam lock on this aluminum block. Notice I'm using mist cooling. That's the brass tube on the left of the milling cutter, and on the right I have a airstream to blast the chips out of the hole so that they don't clog up the milling cutter. The bottom 1/8 inch of the aluminum block is used to hold the aluminum block in the vise. This bottom material will later need to be machined off the cam blocks, and this will be accomplished by removing the aluminum block, turning it upside down, and transferring to the special designed mounting jig in the second vise. Here I'm just trimming off the excess material so that it fits nicely in my jig in the next step. I next lightly sand the tops of the machine cam locks to remove the burrs left on the surface from the machining operations. I'm using a micro mesh pad to sand the tops of the blocks. The resulting set of 5 cams is removed from the vise, and this is the resulting set of 5 cam locks. This is the jig I designed for the second vise to hold the aluminum strip with the 5 cam locks that will enable the machining off of the 1/8 inch thick aluminum base that was previously used to hold the aluminum block in the first vise. Shown here is a block after the 1/8 aluminum base has been machined off. The jig consists of a 1/4 inch wide lip at the top of the jig and then 5 offset cams, one for each of the cam lock blocks to hold them in place during the machining operation. The block with the 5 cam locks is then removed from the first vise, turned upside down, and inserted into this jig in the second vise. The 5 small brass cams are then used to clamp into each of the 5 cam locks. This is accomplished by using a small Allen wrench to turn the center brass cam 1/4 turn. This securely holds each of the blocks to enable the surface to be machined off. A 1 inch diameter end mill is then used to machine off the 1/8 inch thick top surface. Again, this machining was done in several steps in order to get a good finish on the completed cam locks. The brass cam clamps did a good job holding the 5 pieces in place while it's being machined. The clamps are then loosened to remove the 5 cam locks from the jig, and this is the resulting 5 cam locks that were machined in this operation. This concludes this video. These are 2 of the finished cam locks that I machined in this video, showing both the top and bottom surfaces. I was able to machine these to the required dimensions and tolerances as specified in the drawing. I machined a total of 150 of these cam locks. It took me 2 days to complete the machining operation, plus an additional day for the setup, programming, testing, and speeding up of the machining operation. Once again, thank you for watching this video. If you have any questions or comments, please respond in the comments below or send me an email. And thank you.